So here's a fun fact. The very first electric vehicle was produced not in 2000, not even in 1900. No, the very first electric vehicle was produced way back in 1832. Yeah, that's almost 200 years ago, and a mere 54 years after the founding of the United States. According to the U.S. Department of Energy, Robert Anderson is credited with developing the first crude electric vehicle. And he wasn't alone. Engineers in Hungary and in the Netherlands were also independently designing electric vehicles. Electric carriages, actually. It wasn't until the 1870s that electric vehicles became practical and much more common. And in fact, in 1899, advertisements in the local newspapers actually targeted women by pointing out that electric vehicles were not smelly like the gas-driven vehicles. Thomas Edison, of course, was interested, and Porsche, well, they rushed to market a hybrid gas and electric vehicle. And in the first decade of the 20th century, electric cars made up 1/3 of the total vehicles on the road in the United States. Then something happened to the market. The price for gas vehicles plummeted. Up in Detroit, Michigan, there was this guy, Henry Ford, and he figured out how to mass-produce gas-powered Model Ts. This drove the cost way down for consumers, and the Model T, it literally drove the electric cars off the road. Thanks to Mr. Ford, we were then locked into nearly a century of wasteful gasoline consumption, and well on the way toward global warming. Then, suddenly, everything old is new again. As of 2020, there are a lot of new electric vehicle companies out there, such as Fisker, Lucid, Polestar, and Rivian. And there are traditional OEMs such as Audi, Mercedes, GM, and even Toyota. They all have an EV model now. In the United States, the Infrastructure Investment and Jobs Act promises to add nearly 500,000 EV charging stations to power all those new vehicles hitting the road. What's great is that these new EVs use the same charging port technology, more technically known as electric vehicle supply equipment, meaning that you can use a variety of different charging stations as you cross the country. Then again, maybe these generic charging stations are not a good thing. Not without more attention to cybersecurity. This is the story about how the rapid proliferation of EV charging stations is already leading to attacks on the stations and the vehicles themselves. I'm Robert Famosi, and this is Error Code.
My name is Charles Egan. I'm the Chief Technology Officer at Blackberry.
You might be thinking of the mobile phone, but Blackberry today, it's moved on, and it's well into the cybersecurity and IoT space.
As CTO of Blackberry, I work across all the divisions of Blackberry, and the two main components of Blackberry is really our cybersecurity business and our IoT business, and these are two very large focuses within Blackberry. We have a wealth of cybersecurity that focuses on enterprise, government, and all of the cybersecurity domains. And then people may not be familiar with BlackBerry in the IoT space. We're in over 215 million automobiles, and we're a key component of a safety certified operating system and hypervisor. And we're a big part of the connected automobile, the electric automobile, and the autonomous automobile of the future. So the software-defined vehicle is an area, and my particular focus is on the intersection of these two. As automobiles become more connected, how are we going to apply our security best practices to these connected automobiles?
That's the thing about IoT and OT. You can't just shoehorn the best security practices from our networking days into IoT and OT.
When I talk about IoT and I specify the automobile, I'm really, with IoT, it's really all things smart city. So it could be trains, planes, robots, drones, and certainly EV chargers. We're seeing an explosion of EV chargers, and as some people often quote, those who don't learn from history are destined to repeat it. And I think EV chargers being widely deployed without cybersecurity best practices is, let's say, suboptimal.
In 2022, Sandia National Labs team looked at a few entry points, including the vehicle-to-charger connections, wireless communications, vehicle operator interfaces, cloud surfaces, and charge maintenance ports. The good news is that most electrical vehicle chargers use firewalls. They keep it separate from the internet. However, some systems do not.
Cybersecurity is best designed in. And there's a lot of best practices we have today that we can design in to make these EV chargers more secure. We're already seeing, vehicles being bricked, or we're seeing people having fun by creating malicious images on the EV screens because it's such a fun and easy thing to do. So I think we're just seeing the tip of the EV cybersecurity criticality.
Perhaps we should explain how all this works in the real world. If you own an electric car, you don't go to a gas station. Most often, you go to a shopping mall parking lot and find a kiosk there with a digital screen that accepts your purchase of electricity for your car via a card swipe or a connection through your mobile app. EV stations, they may look simple, but they're really complex. It's like an entire gas station, except for the snacks, has been fit inside this tiny kiosk. You have the payment side and you have the charging side. And it's not like a fast outlet on the wall that you can plug into. It's a complex communications ecosystem.
Yeah, well, it's really an M by N combination of communications, because you have near field communication, you have electrical connection, the EV charger is connected to the cloud. There's payment notifications that might be happening out of band to your mobile phone. You need to authenticate the user, you need to authenticate the vehicle, and you also need protocol to vary the charge rate, and so I think the two-way communication quickly becomes necessary. And there's protocols that are merging to try to put guidelines around this, but there's also a certain amount of sort of free-for-all happening, and we can't forget the home chargers.
Wait, so even the power walls at home that are used to rapidly charge your car overnight, they also have vulnerabilities?
Yes, indeed. Yeah, there's been pen testing and lots of documented cases of pretty fundamental security flaws in the home-based chargers. Also, some of those are powered with massive Raspberry Pi engines, and they're thrown together with the right functionality, but without any of the cyber preparedness. And of course, that's connected to your home network, and that's a whole other part of the EV network, the home-based ones as well.
When I'm talking to people about vulnerabilities in IoT, it often becomes a discussion of protocols that are borrowed from the past and brought into the present. It's more convenient to take something off the shelf and get the product out to market first. Well, I wondered if this was the case with EV stations, that demand was so high now that people are just grabbing whatever and saying, here, plug this into your car.
Yeah, at CES this year in 2023, I talked to a number of EV vendors, and one of the patterns I noticed, there's a lot of use of Android technology in the EV charger. That's convenient. It's easy to program the user interface. It's to get it up and running. There's known vulnerabilities in Android, and so I think people tend to focus on the function and they don't focus on cybersecurity. And I think over time, we're evolving with a more cyber capable knowledge base.
Charles mentioned the EV station is running an Android OS. It's performing different tasks, such as when I want to swipe my credit card and when I want to do an NFC transfer with my mobile app. Many of the features are from the cloud. So again, it's not just the kiosk sitting there in the parking lot. It's representative of a much larger communications ecosystem.
The fact that these EV chargers are cloud connected and they're interconnected, they fall in the computer category, and they're probably running some form of Linux or open source, and then the software supply chain becomes something that you need to think about for any kind of sufficiently sophisticated compute node. The software supply chain is starting to increase in sort of scrutiny on how you go about making sure the pedigree of all the software is aligned with what you expect it to be.
In February 2023, researchers discovered two vulnerabilities in the Open Charge Point Protocol, or OCPP, that could be used in a distributed denial of service attack. And also, the Idaho National Laboratory recently found that almost every charger that they examined was running an outdated version of Linux, or had unnecessary services running, and this allowed many services to actually run as root.
It's easy to overlook the adversaries you can't see, but it's, the basement dweller is something you have to worry about, as well as, people seeking profit, malicious, even if, the vehicle to grid potential, if EV cars in the future are used as an energy distribution infrastructure, they could disable the energy grid by a malicious open source attack that tells everyone to draw power or to supply power in an unintended way. So there is a protocol that runs over the power line. So the details of the bricking are sometimes left to the OEMs or the EV chargers. But the fact is that there's wireless protocols that could be running. Like you could have Wi-Fi, Bluetooth, NFC, or RFID tags used for authentication, any type of communication in any direction. One example that I read, Telnet was left unnecessarily on the EV charger.
Whoa, Telnet on port 23 is a client that acts as a terminal and accepts any keystrokes from the keyboard. It's rarely used today. It certainly isn't needed in an EV station or a software-defined vehicle. So getting Shell via Telnet on an EV charging station? Well, that's bad.
And then they're able to do personal information skimming, or they could do charge spoofing, where they report that they're charging, but they're not actually charging, so they're leaving a car in an unenergized state. They could be overcharging and creating damage. I know that the case that I read about, the vehicle was overcharged and stuck on the charger for 2 days before they could get it disconnected. I guess there's some kind of lockout protocol, and they're replacing the OEM is replacing the charge unit. And I guess we'll learn if it was a EV charger or EV or some other reason as these things come out. But there's often a software gateway for payment systems or identification. There might be OEM specific chargers, and these APIs become an attack point for the attack for actors.
We've seen this before, where the connection between systems becomes the weak point, the point that gets attacked. Unfortunately, with EVs, the connection to other systems includes the power grid.
So in the vehicle to grid, the EV is used, all of these vehicles head into an inner city, they plug in, and they have a certain amount of charge that the city could borrow during the day, because they know by the end of the day, as long as the car is at sufficient charge for the commute home, it becomes an efficient way to move energy around a city as the demand for electrification goes up.
Right. So instead of fuel tanks buried beneath the gas station, the EV stations, they have to draw power from the local power grid. And we're talking about a finite amount of electricity that can be moved around from commercial home use to EV use.
But now we're talking about these EV vehicles as being part of the power grid. So you want to make sure the highest level of care is taking on these vehicles if they're going to be operating in this sort of complex dance of an energy balance.
And then there's vehicle to everything connectivity. We've got 5G, which was designed with smart cities in mind to bombard this computer on wheels with tons of incoming data each second, as well as communicating out from the software-defined vehicle a lot of telemetry data. That's a lot of data all at once.
I believe that 5G we're on the precipice of a major disruption. At CES, we had a software-defined vehicle award ceremony with Motor Trend, and they were talking about the software being the most disruptive change in the automotive industry in history. And this is something that, there's a whole bunch of things that are intersecting. The volume of software is going up by orders of magnitude, similar to what we saw in the mobile phone space. Like, we get better, we do learn from history in some cases, like mobile phones are more secure than computers and cars will be more secure than mobile phones.
It's interesting to start to think of our software-defined vehicles as being on parity with our mobile phones, with add-ons and features available to owners simply by means of updates or downloads to their existing vehicle. When the first mobile phones were introduced, they weren't originally smartphones. Then, when we got our smartphones, it was unclear what apps we would absolutely need to have on those phones. Well, that same discovery period is going on now with software-defined vehicles.
5 years ago and to present day, we didn't know which 100 apps we would need on our phone before this software ecosystem was created. The electrification that we've been talking about is significant. The network connectivity is a factor where you're going from a straw to like a fire hose or 10 fire hoses worth of bandwidth. And then you also have the rapid growth of, I guess, driver assist evolution towards autonomous behavior. So, the lane change, the braking, the driver, state detection, driver identity, driver patterns, like there's all these things that are happening. And as we get, this is even before we get full autonomy or more autonomy, but the fact that cars, when they ship today and into the future, will be getting better over time. And they used to just become, more out of date over time. You didn't have a lot of new features being deployed in your vehicle in the past, and we're on the cusp of that happening in the future.
And BlackBerry, they're already thinking ahead on that. They've partnered with Amazon to create apps for software-defined vehicles based on how the vehicle is currently being used.
It's called BlackBerry Ivy, which is a very exciting part of the connected automobile in the future. BlackBerry Ivy, BlackBerry and Amazon got together, and we realized, much like the Google ecosystem in mobile phones created an environment for application developers who weren't part of the phone company, the phone OEM, to bring value to the phone. BlackBerry Ivy is a platform that allows us to abstract data on the vehicle, process it, and provide machine learning on the edge in the vehicle, such that these insights could be made available to application developers to create new capabilities for the connected automobile. So, we can basically take all of the data in the vehicle, provide it up to developers. An example might be, you could do, for example, occupancy detection in a vehicle. You could look at the seat belts or the pressure sensors, and you could actually alarm if there's a child in the back seat not wearing a seatbelt. That's a complex set of sensor manipulation that you could just add that feature in the vehicle, using BlackBerry Ivy. Or EV range anxiety could be another thing. You look at driving pattern, and you look at the EV charging status, and you could provide all kinds of boutique solutions on top of this information to provide a custom experience for you and I driving our EVs. And another thing, an OEM could use it to monitor the vehicle, to do preemptive warranty recall information, because you can use these analytics to figure out if something is aging or operating out of spec. And the idea is you could detect it and fix it without even the user noticing that this has been going on. So there's a whole bunch of potential that, unleashing the power of the cloud in the vehicle allows all of this app innovation going on to sort of also plug into this new connected server that we've been discussing for the last little while.
The computerization of cars and trucks, it isn't entirely new. Cars have had computers since at least the 1970s. These are electronic control units, or ECUs, that are on a chip, And these ECUs are pretty specific and binary. Either the brake is on or it's off. Either the dome light is on or it is off. And connecting these ECUs, up to 70 or maybe even 100 in an average car today, that's the controller area network, a CAN bus. This is a communications ribbon that runs throughout the vehicle, an information highway. All the ECUs contribute to it, so there's a lot of commands and instructions flowing through it. And the individual ECUs, well, they listen for the instructions that were meant for it and it alone. It sounds chaotic, but it's worked for the last 4 decades. And in the absence of one operating system, it's how automotive industry has chosen to handle computerization.
The vehicles are also having a compute consolidation. So the hundreds of tiny little reptiles are being integrated into big mammals. And that means you've now got a hypervisor and guest operating systems and much more sophisticated software running.
Originally, CAN bus required lots of cabling, lots of extra weight. Recently, though, newer cars have moved to the Ethernet system and clustering ECUs around specific areas of the car. Now, with EVs, we're finally layering on an operating system and even hypervisors up into the cloud.
So the CAN bus is staying as sort of, currently relevant communication protocol within vehicles. Certainly Ethernet for higher speed is certainly happening. And, because the CAN bus controllers could be located with the area of the car that they were controlling, now they're tending to be sort of consolidated. I like to call it's becoming a mobile server, and with quite an exoskeleton. It's got 2 tons and 4 wheels, and lots of entertainment going on in it. It's a fun place to be with big screens and all that, but it's fundamentally a server class machine, and it's really a computer network on wheels.
Years ago, I wrote a book, and one of the scenarios was that you could be sitting along the roadside and someone could be maliciously sending you data to mess up your GPS. With all the sensory input coming into a car today, with 5G and all of that, I would imagine it's even worse, that you could really mess somebody up just sitting on the side of the road.
The malicious potential in the software-defined world is, the imagination kind of runs away. There's intended and unintended consequences. You'll probably recall in San Francisco where the autonomous vehicles had a little convention in downtown San Francisco, and people didn't know why all these particular vehicles were congregating. And, the humans were needed to come and untangle that mess.
This actually happened to me the other day. An autonomous driverless cruise stopped ahead of me at a busy intersection. Just stopped, threw on its hazards. The stalled vehicle had started to turn, but stopped, and tied up the intersection in 3 different directions because the driverless vehicle couldn't figure out how to navigate the situation. It was interesting because who do you honk at? And would anybody at Cruise even hear me if I honked?
What's the user interface of a car when there's no object of your affection to apply? Imagine if someone was trying to do that maliciously. A lot of our society operates on people following certain protocols of good behaviors. Like if someone just stops a vehicle and walks away from it, chaos would ensue. The ability to do that remotely, it just sort of opens the mind to the sorts of things that could be maliciously handled. Like if all of a sudden charge stations were pretending to be charging but not charging, and now all of these people can't, it's like running out of fuel. They can't go places, and it just would create havoc.
Researchers have found that not only could data be sniffed from the kiosk connections, but low-powered attacks with software-defined radio could stop a vehicle's charging session from up to 150 feet away. So, you think you plugged in your vehicle and it's getting charged, when in fact it is not. This is more of a problem with EVs. It's not that there's a road service that will drive up and give you a portable battery to juice your car to get yourself home. No, there are actual consequences to these things. There's very much a need for real-world testing of these devices. But remember, these are life-critical systems. Human beings can be hurt when software-defined vehicles crash, both literally and figuratively.
But these are these learnings that we find when autonomous vehicles do have these hiccups, there's a lot of attention that gets applied, and then we figure out how to make this not happen. I like to remind people that cars didn't used to be safe, and now they're very safe. So there's been a lot of safety engineering that's gone into vehicles. Now at BlackBerry, we say safety and security can be interchanged. So we can learn from the safety practices there's some things in safety like your architecture should be partitioned so that compromise in one area doesn't flow into another, or things should run with least privileges. So if someone does attack a particular node, they don't have permission to do that much damage. It's sort of like a rubber hammer philosophy. So they're only able to do so much damage. And I think in cyber, you need to plan to be compromised, or what you're going to do when you are compromised, because it will happen. Like nothing can be prevented 100%. So it's a game of fending, detecting and responding, and trying to reduce the impact, reduce the probability of damage.
Things used to move slowly in the automotive world. I remember back in 2000 when we were told how hybrid cars would be yet another 10 years away. But then the market forced it, and suddenly we had hybrids everywhere. We're seeing the same thing with EVs. We were told it would take a decade or more, and now we have those vehicles sharing the road with us today. This is a much more disruptive change in the automotive industry. Whereas the industry has had mechanical engineers before, it now needs software engineers to create and maintain EVs. I'm wondering if this rush to deliver EVs has the industry deriving any learnings from its previous network security world. I know there was a standard, ISO 26262, which is focused on roadside safety. And then there was the subsequent one, ISO 21434, which addresses soft testing, but mostly from a reliability standpoint.
Yeah, I think like ISO 26262, from a safety certification point of view, and I think it's 21434. And what I look to is WP29 in terms of cyber required. So I think Europe is a little bit ahead of North America in terms of defining the cyber requirements. And I hope that the EV charging network, there's some protocols, like there's ISO 15118-20. It's an international standard for I guess charging, validating trusted identity for charging stations. So I do think that the regulations are emerging. I believe that more is needed, and that the ability to define what good is important. I'm cyber, trust me, is one of the problems in IoT in general, because what does that mean? Because a ton of connected gear has default passwords, doesn't have software updates. It's got, admin gets you in, and if people don't change it, then it just makes it so easy to attack. And so I do believe that the standards is going to be an important part of cyber. And I also think there's sort of when I think about, I see the cyber excellence that's happening in the cyber world, where half of our company is focused. And then I look at the IoT world, and I think, okay, the IoT world needs to learn more about cyber, but the cyber world needs to learn more about IoT. When I talked to a cyber colleague about Sam Curry's published automobile hacks, he said, oh, that's traditional AppSec security. Like that's kind of what I would have expected. But the cyber people aren't looking at the automotive side because it feels like a different canvas. Like it's a car, it's not a computer. And so I do think the combining of those two disciplines is a really exciting area for us to get our defenses in place faster to reduce the churn and complexity that we're going to be experiencing.
Sam Curry's work was on the APIs. This is the interface between the mobile app and the automobile. But I would think such fun and games have been dealt with in the security world before. So, it's interesting that the automobile engineers are having a hard time wrapping their brains around the idea that this is no longer a car or a truck, it's actually a server on wheels. So maybe there's a fundamental mismatch in thinking.
I just think that the traditional cybersecurity professionals are looking at Windows servers, Linux servers, and it's sort of it. You need to squint a little bit to realize it's exactly the same thing. We're using internet communication. We have lots of Linux copies in there. There's probably not as much Windows, but the software supply chain is very similar. A lot of open source. So I think it's there's plenty of challenges over in the cyber domain to keep people busy too. The area of IoT, and in general, I think when you start to mix disciplines, there's a certain amount of cross-pollination that happens. You can't just take a cyber solution that exists in the enterprise world and apply it to an automobile, because that's an embedded system, and that embedded system needs a certain approach for reduced memory. Perhaps it needs to operate better in an intermittently connected state due to the lovely tunnels in San Francisco, or remote lands of Canada, or many parts of the U.S. where connectivity isn't guaranteed. So I think intermittent connectivity is part of it, and the automobile also has this type approval or safety approval that means the software needs to go through extra controls before it can be updated. So it is a different operational paradigm.
That's very interesting. So the software on the vehicle can be updated. However, the OEM has to first check the controls to see whether that part of the car can be safely updated.
Yeah, so for the safety certified systems, there needs to be a type approval before the software is updated on the vehicle. Now, of course, with our infotainment system, there's applications that you can download. You're basically running Android in your console, and that doesn't have to go through type approval. It's the safety certified components that have an extra approval process to go through to make sure that it meets all the checks and balances of some of the regulations.
And you don't want that update executing while you're driving down the road at 60 miles an hour.
No. The software updates need to be much more carefully tuned because of the kinetic reality of the moving automobile. And so that's the question too. When you detect a cyber attack, let's say in a vehicle in motion, what's your remediation plan? Can you go to a safe mode of operation, because you need to take into account the whole environment that's going on?
Charles touched upon a couple points, one being the supply chain. The fact that there's a brand associated with the car doesn't necessarily talk about the tiers of suppliers that are contributing to that car. For example, the G-Pack in 2015 was because of a vulnerability in a Tier 1 supplier, yet Fiat Chrysler, they were the brand that was damaged by the whole event.
Yeah, so I think everyone in the supply chain needs to be able to show their pedigree on the way through. We've learned through some of the cyber attacks that even the software supply chain protection isn't enough. You need to look at the build process and the transmission of it. The supply chain of the automotive environment, really, you need to check all the components along the way. And we actually have from our history in mobile and with our automotive focus, we have something that is actually a binary code scanner called Blackberry Jarvis, and it looks at the binary code to give you the assurance that every component was built to the right specifications, and it looks for anything within the build or the source code that could have been compromised. Even the compiler flags are looked at. So you really looking at the binary is one of the only ways to make sure that you have the proper software. The OTA or the over-the-air software updates needs very strict security credentials to make sure that the software that you're uploading is the software that you've intended, and so you need very good signing on the vehicle, signing of the software, and controlled understanding of who was supplying it. But there's been cases of software update where the intended software was intended, let's say, for a uh, a Google feature running on the vehicle, but the ability to restrict software updates to the high-level software wasn't implemented on the vehicle. So through an app update, they were effectively able to change the low-level controls of the vehicle. And so this is just another one of the happy path cannot be ever counted on. The unhappy path is what you need to really fixate on and make sure you've done limited privileges, and you can only update the area of the vehicle that you intend to update. And this is where our notion of zero trust security, like zero trust, make sure the operation that's happening is allowed to happen. The person is the person or system that's supposed to be doing that. Because if a malicious piece of software comes in and says brake hard or turn right, then you can detect that this is a malicious command. And so if the car is accelerating, but the cruise control or accelerator hasn't been applied, you could say, okay, this is an unexpected reaction without a stimulus. So you can start to use rules and potentially machine learning to determine safe operations.
A moment ago, we talked about the CAN bus. And what the CAN bus does is it connects various ECUs, electronic control units, stationed throughout the car. So there's one for braking, there's one for steering, there's one for your lights, etc. That's good in the sense that you now have a diversity within the ecosystem of the vehicle. However, when we're talking about a software-defined vehicle with an operating system, well, that may not be the case anymore.
Cybersecurity is a yin and yang. So there's certainly parts of a large-scale system with a hypervisor and RTOSes that has it naturally partitioned, and that's goodness. The problem that arises on the yang part of this is that there's a large-scale use of open source, for example, or communication protocols, or the software stacks that are being used could be open to compromise, and so the ability to move laterally is influenced by the fact that some of this software, in the old days, we used to talk about security through obscurity. They were very embedded systems. They were built by, the rarest of software developers, and they were very hard to communicate with because it was difficult. But now that hundreds of millions of vehicles are running the software that kind of looks like the software that, is running other places in the world, the attack vector, because we have payment systems and more volume of this activity, it becomes more targeted. But there is often oversight. People design for what I call the happy path, and they don't take into account the malicious actor, which is anyone on planet Earth, anyone in the supply chain is now a potential threat. So as the software-defined vehicle proliferates all of this software, that's where the attack vectors come as well, because without the hardware attacks, you had to be geolocated, and you could expose a CAN bus and start to do denial of service or spoofing or something on a CAN bus. But now that CAN bus cable, it goes all over the planet.
One of the ways in which BlackBerry is contributing to the safety and security of the vehicle is through an RTOS operating system known as QNX.
So BlackBerry QNX is a great, it's a real-time operating system. It's a POSIX, so it's a very, very compatible to Unix or Linux systems. It's been around for 40 years. It's used in high assurance applications, so where you really need to make sure something runs fast and runs safely, QNX is your technology. So there's a BlackBerry QNX hypervisor, which is safety certified and used in automotive. There's a BlackBerry QNX operating system that runs on top of the hypervisor, and basically Linux-like. Think of the type of services that you get in Linux. There's also safety certified libraries that come from QNX. So there's a good acoustics portfolio, which is relevant to audiophiles and used extensively with things like echo cancellation and noise suppression, which is really important in an automobile. So it is really the de facto standard operating system in automotive today, running in over 215 million cars. There's a number of other technologies too. We have a subcomponent of BlackBerry QNX, which is called Certicom, that is an encryption specialist. It has quantum crypto-ready software OTA updates. It's got PKI signing capabilities. In terms of cyber certifications, that's another area that BlackBerry is well positioned in.
Given all the disparaging things we've said, there's actually a bright future for smart vehicles and EV powering stations in the future.
Yeah, I'm very excited about the software-defined vehicle and the kind of innovation and creativity that will be applied. Cars will be safer, cars will be more autonomous, and there's going to be much appreciated efficiencies, be it towards more environmental capabilities, safer, better entertainment. I really believe that the magic, as a career software person, the potential for software is what we saw happen with mobile phones will happen with the capabilities that are being unleashed in the software-defined vehicle. So my vision is more safety, more autonomy, and safer. So we just need to learn from the past to put some good protection in place. Hope is not a good cybersecurity strategy.
And for the charging stations, I would think that there might be some best practices that would help us secure them further in the future. So
the good thing about our cybersecurity knowledge and our communication knowledge is if we put some of the learnings of cyber and best practices in place, we can make EV charging and hence connected automobiles and electric automobiles safer. And I think some of these best practice falls into using trusted components, for example. So if you wanted to take from the automotive industry and use a safety certified operating system, that goes a long way towards providing protectedness because all the pedigree of that OS has been verified. The other thing, you should use trusted components. So you should have proper certification and signing of the hardware so the identity can be detected. And you should design your system to be very partitioned such that one component cannot maliciously influence another component. The need for monitoring an EV charger is also high. So if you just deploy something and you're not verifying that it's running within its expected parameters, then an attacker has all the time in the world to perform an attack. So having some kind of active monitoring and probably cloud-based monitoring so that you don't have to be located would also be a best practice so that you have the ability to address any kind of compromise in short order. So I think some of these, supply chain, software supply chain, hardware supply chain, and sort of continuous monitoring are some of the things that help make EV chargers more stable and more protected. And I think as the regulations unfold and the best practices, be it from NIST or other expert groups in Europe, I think following these best practices would be recommended for the EV chargers. And then you and I can enjoy our EVs with the peace of mind that we want.
I'd like to thank Charles Egan for talking about the threats presented by the EV charging stations on the road today, and also the possibilities of what software-defined vehicles will provide for us in the future. As Charles said, we're seeing an evolution. Our mobile phones are more secure than our desktops, and I have no doubt that our software-defined vehicles will be more secure than our mobile phones. We just have to work hard to get there. Hey, if you're enjoying Error Code, tell a friend. I'm sure there are other people out there who like narrative information security podcasts. And I'd really like to hear from you. DM me at robertvamosi@infosec.exchange on Mastodon and tell me what you like and even what you don't. And coming up, I've got some great episodes talking about a deep dive into what we mean by the electrical grid and how secure is it really. I hope you'll subscribe so you don't miss out.